Now let's do a more complicated crashing problem. Here we have a fairly complex network of activities. Up here we have our table, normal times indicated in the cells, normal costs, total up to 2,000. We have our crash times available. They vary from 3 days off of activity D to you can't crash activity A, therefore it gets an X. We've got the costs of crashing per unit, 100 and 100 for B and I, 30 for, let's say, activity E. And because this is a little more complicated, I've taken the time to plot out the different paths to make sure I know what the critical path is. And as it turns out, we have two critical paths in this network. We've got the outer one, which adds up to 21, and the bottom outer one, which adds up to 21. And the ACDGI one is 20, and the ACDHI one is 20. All four of those are valid paths. So, even though it's a little more complicated, the same principles apply. We identify the critical path like we did, and then choose the cheapest activities along the critical path to shorten the duration of the project. And so what I've done is again listed the two critical paths and recorded the crash cost for each of the activities, putting the X under A since we can't crash that. And we look at this, we have the opportunity to crash just one activity, I, and influence both paths, like we did in the earlier problem. But in this case, it's actually cheaper to crash two activities instead of the final activity. F is cheaper than G, and either C or E could be crashed in conjunction with F, and that would be a cost of 80 to get down to 20. So now we have a choice, C or E. I choose C. Why? Well, if you look at the network, if you choose C and crash C, you also influence the two inner paths, and you prevent them from becoming sensitive or critical. And so here, there's an additional advantage of choosing C. It costs the same as E, but it prevents these two inner paths from becoming critical, and therefore you choose C as the optimum solution, along with F. Notice we now have the duration at 20. I've added the cost of crashing F and C, raising it up to 2,080. I recorded those changes. C gets an X. F, we can still crash some more, so it doesn't get an X. And we have a new schedule with a duration of 20. We go through the process like I did to see if the critical paths change. And sure enough, by crashing C, we prevented those two inner paths from becoming critical. And again, we need to influence the two outer paths. We look at the options, and again, we could do I, but F and E is still cheaper than I. 50 for F, 30 for E. So to go from 20 to 19, it can only cost us 80 if we choose those two activities, and that's what we'll do next. Now by crashing E and F, we've got the network to 19 at a total cost of 2,160. I recorded those changes, and sure enough, now when we plot out the critical paths, we realize that all four paths are critical at the duration of 19. So now we have to influence all four paths in order to go from 19 to 18. Influencing just one won't alter the duration of the project. All four have to be affected. So I've drawn out the options here. B is 100, D is 50, H is 70, E is 30. We look at the different combinations, and sure enough, even though I is expensive, we are really, in this case, killing 4 birds with one stone. We influence all four paths, and it's cheaper than any combination of the other 3 or 4 activities available. So we'd go ahead and change I to go from 19 to 18. So here we have the network schedule at 18. I've gone ahead and recorded the change in I, put an X next to it because it's reached its crash point. And now I've recalculated the critical paths. And not surprisingly, all 4 of them are still critical, as you would expect. And again, we face the challenge of influencing all 4 paths. We go down here to see what our options and the costs are. The X's are next to the ones that we've already crashed and can't be crashed. And we look here, we've got B, F, and G, DG, DH, or EH. And here, when we look at the different combinations, we realize that by crashing G and H, we influence all 4 paths, and that's a cheaper solution than any other combination of the other activities available. So to go from 18 to 17, the cheapest solution is to crash both G and H. So now we have the network at 17 with a cost of $2,400 when we add the cost of crashing G and H to the previous total. Again, we look at our networks. Now we're at 17. We have all 4 critical paths. And now we look at our options. They're becoming fewer and fewer as we continue our way in reducing this network. And now in terms of A, B, F, G, I, the only task that we can crash is B, so we have to do that for sure. Same with D, 50-50, and E is 30. So we have to crash B, D, and E to get from 17 to 16. So I've gone ahead and crashed B, D, and E, added the cost to $2,580 to get a duration of 16. We check our critical paths, all 4 are critical. We look down here at our options, and yes, we can crash B. We can still crash D and influence the 2 inner paths. But the bottom path, none of the activities on A, C, E, H, I path are available to be crashed. There's X's across the board, and when you see that, you now realize that you've reached the crash point. This network can't be reduced any further than 16, given the information that we have.